everybody. First of all, I would like to thank Fred for year over year getting this type of event going, getting us all together here. I know that he spends a lot of time and effort on this, so thank you. Thank you, Fred. My name is Luis. I've been here year over year as well, so it's good to be back every year that I'm here. Last year I did some session similar to this. So who was actually here last year? And okay, then my session. So this is kind of like a continuation to last year's session, more focused on observability and operations on group replication. So who am I? I'm Luis. I've been with MySQL for over 15 years now. I'm mostly doing MySQL replication for a long time, and also anything related to HA. I live in Portugal. I like physics, astronomy. Obviously I like distributed systems. It's my background. It's what I love to do. And I'm a long timer MySQL, as I said. So this is the agenda for today's session. So some introduction. We'll talk about observability. We'll talk about automation. We'll talk about operations. And what I'll try to do is talk about the new things that happened between then and now, between last year and now. If there's anything that was released before, I will call it out. So when we talk about observability, automation, and operations within the context of distributed systems, a thing that lives and breathes on its own, we always have to, it's a complex thing. When you think about things like high availability, many servers working together so that if there's a fault in the system that causes a failure, that thing doesn't result in an error to the end user, right? So that's the whole point of this. Keep things alive and running, even if there are latent faults that result in failures. So this is hard. Same thing for inbound replication, outbound replication. It's all about getting all these different instances talking to each other, making sure that they can coordinate things among themselves without requiring human intervention. Bring in managed read replicas and point-in-time restore or point-in-time recovery. That's another type of, or another instance of the same type of problems, if you will. With the MHS, or the MySQL Heatwave service, what we try to do is to hide this away from you, right? We try to take all the burden of handling these things when things actually go wrong, keeping these things running as well, and only give you a service that allows you to focus on writing your application, engaging the database, and so on and so forth. So doing this at scale is also, it's another dimension, another factor of complexity added to this whole story, right? So this is really cool. This is really hard, but really challenging and really rewarding when things actually work. Such as MySQL Heatwave service. But MySQL is also everywhere, and we had Miguel here talking about the MySQL shell, admin API, and getting all these things working, even if you're the one doing and running your system, you always need something like the MySQL shell, and the same type of problems will come up. So it's good to have all these things working together, not just plain technology like GR, but toolkits or a set of tools that will help you do it, run it for you, and automate it for you, and observe it as well. So there's still the need to run, monitor, and operate, whether you're in the service or whether you're on-premise. So when we talk about observability, we talk about, okay, should we instrument? How do we instrument? How do we do it without taking a performance hit? Is it about pulling things from the server? Is it about emitting things from the server? Is it about when I talk about server, I could actually say server infrastructure, whatever, right? Whatever the thing that is running, we need to observe, right? And then the automation is all about, okay, I want to be able to deal with some weird situations. I maybe want to rebalance things because of, the load is different during this point in time, and then maybe you have peaks and then you don't have peaks anymore. So it's all about automating your system to cope with all these things. And then operate. Sometimes automation doesn't really do what it's supposed to do. Maybe there's bugs, or maybe it's not as feature complete as you would think, as you would like. And then, of course, a human has to come in and operate, but all these things. So there has to be knobs in place for the human to turn. So yes, this is a continuation from last year's session. And let's do a quick recap. So last year we talked about
astrophysics.
Fermions, right? So do we remember that? What is a fermion? Right? It's a particle that has a spin of a half spin, basically. And we talked about bosons as well, right? And a boson is, an example of a boson is a photon, right? And because of that, we also talked about the double slit experiment that was done by Thomas Young in the 1800s, right? So basically, what Thomas Young, just a quick recap, what Thomas Young did was, I'm going to fire, or I'm going to shoot, or I'm going to throw light through a sheet of paper that has two openings and see what happens when the light goes through these two slits. What happens in the back of this paper? So it has another sheet of paper in the background, in front of it a sheet of paper with two slits, and then throw light through these two slits and see what happens. Well, the result was weird, and it's still weird, right? Because we can't really tell what's happening there, because instead of having two bars of light in the background sheet, what we saw, or what Thomas Young saw at the time, was that there is a wave, a pattern that is basically a wave on the background sheet. So this is weird, right? Why isn't just two bars, and instead it's more like a wave pattern? So this went on, and later there were more experiences done on this, and the weirdest thing happened, which was, okay, if I try to look at a photon that's going through these two slits, I can see that the photon either goes through one or the other. But if I try to observe it and detect it, I stop seeing the interference pattern. I see the two bars. I don't see the wave pattern anymore. And this is the duality of the wave particle for these elementary particles, right? So they can behave as a wave, they can behave as a particle. But you don't really know. You need to observe. You need to look at it and see exactly what it's doing. And once you do it, the universe, or the multi-universes will collapse into a reality, right? So that's one thing. Until you see it, you can speculate, and you can think about things. You can say, okay, maybe this system is behaving this way or the other, but you have to observe to actually detect what's going on. And there's another thing, which is, what's the speed of light, right? Do we know? Anybody? Right. Speed of light, right? So once we see it, we're seeing it as it was some time ago, right? It's not how it is right now. So the reason I'm bringing this all up again is because we need to observe, and when we talk about distributed systems, and when we talk about machines communicating to each other, we have to consider physics too, right? We have to think that whatever we're seeing at a given point in time may not necessarily be what's actually happening then, right? So, and until we see it, there's a multitude of things that can be happening, and we can speculate, and it's really hard to troubleshoot and work on assumptions if you don't actually have the data to back it up, right? So, last year we talked about this, so this was a quick recap, but we also talked about, okay, but when we talk about GR and so on, maybe it would be better that we could observe it, get more information, more stats about what's going on with respect to the communication amongst the different servers, right? And that's what we did. We instrumented GR to display statistics about, okay, what's going on in the network? What's going on when I try to send a signal from this machine to that other machine? Is it reaching this other machine? Is it the network problem? Is it the instance problem? What's going on, right? So when we talk about GR, we usually have to talk about things like server stocks talk between themselves to propagate data. Server stocks talk between themselves to propagate control messages, right? That's all there is. It's either data or the rest. And in GR, servers talk amongst themselves by running a Paxos consensus or a set of Paxos rounds to achieve consensus on the matter. So that they are in sync, coordinated, so that they make progress together, right? So that they don't go on their own, so that there's no multiple realities in this situation, right? So with Paxos come things like roles, server is either a leader, an acceptor, a learner. There's things like turns, slots, rounds, ballots. So this is more of Paxos terminology. But it is a reality that in our software we have this, right? And then we have optimizations done in the Paxos implementation, like, okay, we're doing things like multi-Paxos and maybe something derived from Mensch's variation of Paxos too. So there are certain optimizations that have some impacts in terms of latency and throughput of the system. So things like proposing and agreeing on messages, are we doing it really fast? Are we doing it slower, and why? Because maybe due to connectivity issues, I'm not able to do these optimizations, so I should be able to observe these things. And that's what we did. So I'm not going to spend so much more time on this because there was a good session here, I think it was 6 years ago, by Alfranio. And there's also a great blog post about these underlying optimizations and how GR works, how Paxos works in our implementation and so on. So I'll leave it at that. But the important thing is, because all of this complexity, because of how these algorithms work, sometimes it's hard to understand what is actually going on without getting data to back it up. And we created this, we started to instrument more and more, and we export this data now in our performance schema tables to expose some of this. So if I'm a user and I'm seeing, okay, what's going on here, because all of a sudden my transactions are now taking a little bit longer. Why? And in this case here, we see, okay, there's something that happened in the network here that translates into an amplification in transaction execution latency within the cluster. So what's going on here? Is this due to increased network latency? Is some member just unstable and unable to communicate, and therefore that has implications on what package optimizations can kick in or not? Is just garbage collection taking a lot of time? So am I just doing background communication to garbage collect some of the metadata within the cluster? What's going on here? So in this case, the user logged in into server 3, and it noticed, okay, there's actually one server that seems to be unreachable. So that must have some implication on the communication between the servers and the coordination between the servers. So how many times has it been unreachable? And from now, from 8.1 onwards, you can actually have this data and say, okay, this guy was actually suspected to be bad or muted a few times. Okay, so there's something weird going on here with the connectivity between the servers. All right, so what's happening here? Something is not quite right. I wonder if the added latency is actually due to this. So we can then go and see, okay, seems to be that we had to run some extended Paxos rounds because this guy was muted and some optimization here was not able to kick in, and therefore to be able to reach consensus, we needed 1 or 2 more phases of Paxos, right? So this is the type of realization that we can do with this new data. Well, this doesn't, just by looking at the data, you can just, without knowing more about the underlying how Paxos works and so on, it's hard to just extrapolate what's going on. But this gives you a good indication, and then by reading the manual and the blog posts, you can figure out, okay, there's something that goes on in the network here. Maybe it's either the network or the servers are overloaded or something. There was some spike in the resource usage that caused these optimizations to not kick in. This is just a simple exercise. There are other examples like why is garbage collection taking so much time and so on and so forth. So this can also be drawn by these tables. So I'll talk a little bit about automation as well. This is actually a feature that, okay, so this was complete switch of topic now, right? So I'm going to talk about a new feature that helps. I classified it as automation in the sense that many people, they say, I wanted to use this, but I don't have primary keys. And well, you should have primary keys, but I don't have. Right? So many people say, well, they find themselves in this situation. And what we did was, okay, let's create an implicit hidden primary key for you that is unique across multiple instances. It's not instance specific. And therefore, we created this feature. So there's a feature in MySQL Server that if you create a table without a primary key, it can assign a primary key for you automatically, right? And I classify this as automation because it's something that you don't have to do, even though you should. You don't have to do if you haven't. And therefore, it's automation that works for you. So, as I said, this is a safety net type of feature. It's not really something that you should rely on. You should prepare in advance, think about your schema and so on. But there's this safety net if you want to use it.
And does it replicate safely? I don't think it does.
It does.
It does?
Right. So,
oops. Because it doesn't, I thought it replicates the same command, which doesn't necessarily, that's changed now.
No. So, in this case, server 4, let's say that this is MHS, a DB system in MHS, right? And server 4 is an on-premise service, so you're doing inbound replication, right? You create a table without the primary key on-premise, goes into the service. This guy executes, creates the table with the primary key, and then logs in the bin log. This creates a statement.
Oh, it's a different statement. You change the
right? So downstream, they will all see the same table specification, right? This it says small nuances, right? Because downstream from this guy, now you have a table which has an additional column, right? So things like, okay, now I'm going to do outbound, back to on-premise. Now you have an extra column. So this is a safety net feature. You should think in advance to have primary keys if you don't. So keep that in mind, right? In the MySQL Heatwave service, you can actually, when you're configuring your DB system, you can, or your channel actually, you can select, okay, I want to use a channel that is going to have this automatic primary key feature enabled. So the channel will handle it for you, just as I mentioned before, right? Again, safety net type of feature. And one thing we did as well to further reduce the effort on humans and automation is to remove transactions generated in binlog due to view changes, due to membership change. This is not so great, but if you're doing cross inter-cluster replication and all of a sudden you have some transactions in one cluster that are local to that cluster because there were membership changes which are not in the other cluster. So you have a primary cluster, a secondary cluster, and this guy has more transactions than this guy. And then you don't really know, wait, what's going on here? Are there local transactions? Are these two clusters diverging? I don't know. So these transactions, these could happen because of membership changes from 8.3 onwards.
Yeah, we had to handle that in cluster state.
Yeah, so from 8.3.0 onwards, that's not the case anymore. So these things don't, there will not be additional transactions in this cluster due to membership changes. So things make more sense.
Except if the cluster crashes.
Except if the cluster crashes.
Because then you don't know the previous membership played.
But
To bring it up, you can't come up on its own.
That's a fucking problem.
But that's orthogonal.
Yeah.
Operate. I'm just going to quickly mention here that, okay, you can operate these features, right? You can, okay, I don't want global, generic primary keys, generated primary keys, implicit primary keys anymore. Let me just turn it off or turn it on and so on and so forth, right? So you can do it using the normal change replication to source to command to configure the replication channel. So nothing really, it's no rocket science here. Well, this is the behavior of this feature. And I'm going to keep it short because this is a continuation from last year's session and I'm talking about the new stuff. So all of the things that I talked about is new stuff that happened between then and now, except for the thing that I called out earlier, right, about this generic implicit primary key. So one thing to keep in mind, we talked about replications earlier, we talked about cross-version replication, so on and so forth, but keep in mind also that things like, you should move from this old terminology into the new terminology if you haven't done so, right? So we've also been working hard on modernizing the MySQL API or user interface, removing all these offensive statements like master and slave. So if you haven't moved on from this terminology, you should. Okay, I have 3 minutes left. Let me just say that all this thing and complexity and operating and monitoring and so on, if you're running the system yourself, it's on you. But if you don't want to take that burden, there's always the MySQL Heatwave service, which, one click away can just enable or launch a DB system with high availability, everything monitored, everything operated by the service. You don't have to do it, right? Same thing goes for backups, point-in-time recovery. Same thing for high availability. So all to say that the service builds a lot on these features that we build and produce to make it easier for us to operate, manage, run, observe, hide complexity from our users, right? So observed, automated, and operated by MySQL experts. So that's one takeaway from this too. So to conclude, yeah, replication is, in its innovation release has been extended, enhanced over the years, over this last year included. And we have the MySQL Heatwave service that runs and operates on top of the features that we've been developing, and that we're also using too, right? So that's my session. Thank you all. Yeah.